Okay, so we are going to go to page 62. Okay, we're going to analyze the axis of symmetry for f of x equals ax squared plus bx plus c. We're going to evaluate f of x equals ax squared plus bx plus c for x equals 0. Okay, so before we do that, we need to know what this is. Okay, standard form of a quadratic function is f of x equals ax squared plus bx plus c. Okay, a, b, and c are just numbers. They can be any numbers. Okay, we've already talked a little bit about the a value. The a value of a quadratic talks about stretching and shrinking and reflecting. This is the same a value that you would see in a vertex form. So it talks about negative. If it was negative, then my parabola would face down. It would reflect across the x-axis. Okay, if a was greater than 1, it would be a stretch, vertical stretch. If a was a decimal or a fraction in between 0 and 1, then it would be a shrink. Okay, b and c are new to you. Okay, they're just numbers. They're just representing numbers here. Okay, but we will talk about them today. Okay, so we asked you to evaluate when x is 0. Find f of 0 when x is 0. So all we're going to do is plug in 0 for x and solve. So I have f of 0 equals it's a little lagging here. Will not let me write. Not good. It thinks it's an eraser. There we go. A times 0 squared plus b 0 plus c. Okay, then we're just going to do the math. F of 0 equals 0 squared. What's 0 squared, class? 0 plus b times 0 is 0 plus c. Then what's a times 0, class? 0 plus 0 plus c. What's 0 plus 0 plus c? C. Okay, so f of 0 is c. Okay, what we've just proved is that when x is 0, the c value is always the y. Okay. Do we know that's called when x is 0? What do we call that? It's a key feature of a graph. Not the origin, because origin would be when x and y are both 0. Okay. What we just proved is that the c value is the y-intercept, where it crosses the y-axis. Okay. Okay, so the C value of a quadratic function, write this down, please, in standard form. Is the y-intercept. Okay, do you remember what an intercept is? Say, if I say y-intercept, what does that mean? Yeah, Gabriel? Very good. The y-intercept is where it crosses the y-axis. Just like the x-intercept would be where it crosses the x-axis. Okay, so write that down if you don't remember. Not the x-axis, but the y-axis. Okay, x equals 0. Okay, so it doesn't matter what the value of C is. When I plug in 0 for x, the y-intercept is always going to be whatever that C value is in the equation. Does that make sense? Okay. Okay, so let's move down to this one. Okay, we're going to write small, just so you know. There's a lot of work to be shown here, and there's not a lot of room to show that work. You might need to go down here. We're not going to answer this question. So if you need some extra room, you can write down here. Okay. We're going to graph each function. What are the y-intercepts and the axis of symmetry and the vertex of each function? Okay. We should easily be able to identify the y-intercept right off the bat. Okay, does anyone think they know, looking at this equation, what the y-intercept is? Yep. 4, okay? We just showed you that the C value, this is the C value, the number all by itself with no variable, that is the y-intercept. It is 0 for x and 4 for y. Any questions over that? The next thing they ask you to find is the axis of symmetry. Right over here, we need to identify what the axis of symmetry is. There is a formula to find the axis of symmetry. It is x equals negative b over 2a. X equals negative b over 2a. Okay. So over here, we need to know what to do here. Okay. The a value is the number in front of the x squared. We've already determined that when we did it when we graphed in vertex form. So the a value is 1 here. What's new to us is that b value. The b value is the number by the x, which is 2. The c value we already found. It is the y-intercept, so the c value is 4. Any questions over that? Okay. So now to find the axis of symmetry, we're going to plug it in. Okay, I'm going to do it right here on the side. So x equals negative b over 2a. When I plug it in, I get a negative 2. It changes the sign because it's a negative b. So the 2 now becomes negative. Divided by 2. Yeah, go for it.
Brandon? Ashley? Thank you.
You're welcome. Divided by 2 times the a value, which was 1. Okay, then we do the math. Negative 2 divided by 2 times 1 is going to give me x equals negative 2 divided by 2. And negative 2 divided by 2 is negative 1. So x equals negative 1. Does that make sense? Okay, now the next part is to find the vertex. So we're going to go over here and talk about how to find the vertex. Plug in the axis of sim into the equation. And find f of x, or the y value. So we know that the axis of sim is part of the vertex. So in this case, I have the very first piece of the vertex. My vertex starts with negative 1. What I need to know is what the y value is in that, or the f of x value. So now if I plug in negative 1 in for x into my original equation, I can find that. So I'm going to do that work down here. So I'm going to have f of negative 1 equals, lots of scrolling through colors, negative 1 squared plus 2 times negative 1 and then plus 4. Okay, so I'm just substituting it in for x. Anywhere I see an x, I plug in negative 1. Now we're going to solve. So I'm going to do f of negative 1. Ooh. F of negative 1 equals negative 1 squared is 1. 2 times negative 1 is negative 2 plus 4. Keep going. F of negative 1. 1 minus 2 is negative 1 plus 3. So f of negative 1 equals -1 plus 3 is 2. What's the plus 4? Is the c value x squared? I plugged into this equation, x squared plus 2x plus 4. Oh, thank you. I don't know why I put 3 there. I probably did it in my head quickly and then, okay, let's try that again. -1 plus 4 is what? 3. Thank you. For those of you who are fixing my random mistakes. Paying attention, I love it. Okay, so our vertex now is when x is -1, y is 3. Okay, so now we can graph. I'm going to draw my axis. Okay, here's the x-axis. Make it a little thicker. I'm going to draw the x-axis down here because I know my parabola faces up. The a value is positive and my vertex is at -1, 3. So most of my parabola is above the x-axis. So I need to show some room there. So I'm going to graph where x is -1 and y is 3, 1, 2, 3. That's my vertex. Then I'm going to graph the axis of symmetry that goes right down the center of it. Then I'm going to graph my y-intercept at 0 for x and 4 for y. Okay, that's my y-intercept. Okay. Because I have the axis of symmetry, I can show the other point on the other side. Okay? Because I have the same point just on the other side of the axis of symmetry, which is right here. This is what we call the mirror image. Of the y-intercept. Okay. Since I have 3 points now, I can graph the parabola and show how the width of it. Yes. The what? The blue one is the y-intercept, right? 0, 4 is my y-intercept. And this is the mirror image of it. So now this is my parabola. Any questions over that? We're all good? Okay, let's do another one. Okay, Brandon, what is the y-intercept here? Very good. So my y-intercept in this one is 0 for x and -4, because that is -4. Okay, the next thing we need to find is the axis of symmetry. X equals -b over 2a. Okay. Catherine, what's the a value? Negative 0.75, yes. Yazid, what is the B value then? 3. You already have the C value of negative 4. So we're going to plug it into our equation for the axis of symmetry. So we're going to have x equals negative b, which is 3, so it changes the sign to a negative 3, divided by 2 times negative 0.75. Yes. Very good. So let's do that math. So we get x equals negative 3 divided by 75 cents twice. Means I have $1.50, right? So when we multiply that, we get negative 1.5. Then negative 3 divided by negative 1.5. Negative divided by negative makes it positive, and 3 divided by 1.5 is 2. So our axis of symmetry is x equals 2. Any questions over that? Okay, now we need to plug it in. So let's plug it into our equation. So g of 2 equals negative 0.75 times 2 squared plus 3 times 2 minus 4. So g of 2 equals 2 squared is 4. 3 times 2 is 6 minus 4. Okay, negative 0.75 times 4. It's basically 75% of 4, which is 1, and a negative. So not 1. 3, and it's negative. 0.75 times 4 is 3, and it's a negative, plus 6 minus 4. Negative 3 plus 6 is 3 minus 4. And then g of 2, 3 minus 4 is negative 1. Did I do that right, guys? Okay, so my vertex now is at 2 for x and negative 1 for y. So I'm going to draw my axis, my x and y axis. If it'll let me. Okay, my parabola is facing down. So I kind of need to put my x-axis up here. The vertex is at 2 and 1. So I'm going to go where x is 2 and y is -1. So that's my vertex. I'm going to draw my axis of symmetry right down the center. And then I'm going to graph the y-intercept. It's at 0 and then -4. So 1, 2, 3, 4. So that's my y-intercept. That's really bad writing. Okay, so then we're going to graph the mirror image, which is on this side. It was 2 away here, so it's going to be 2 away here. So then my parabola is going to look a little bit fatter because the a value is in between 0 and 1. The absolute value of a is in between 0 and 1. Any questions over that? We're all good? Okay, go to the back page and try number 5. Graph that for me. So we found our vertex to be -2, -9. So we should have our x and y axis. The x-axis should be pretty high. So I can count down 9. So then my vertex is going to be at -2. So here's -2, and then -9 is down here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then we have to graph the y-intercept, which is at -1, 0, which is right here. And I'm going to graph the axis of symmetry right down here. In order to see how wide the parabola is, I use that axis of symmetry and find the mirror image. So the mirror image of the y-intercept is going to be 2 away on the other side. So it's right there. And then I'm going to graph my parabola by connecting my dots. Just like that. Any questions over that? We're good? Okay, we're going to go back to page, whatever this page is. Page 63. It's going to ask us to compare. Compare f of x equals -0.3 x squared minus 0.6x minus 0.2 to the function g shown in the graph. What are the maximum values? Which function has the greater maximum value? Okay. So this is what they're calling g of x. This is g of x. Okay. They want us to compare an equation to a graph. They are not the same. They are different. So this equation It says it has a maximum value. Can someone tell me what the maximum value is? Yeah? Okay, very good. The maximum value is going to be that vertex. Okay, so let's write that in. Value. So in this case, the maximum y value here is 0. Any questions over that? So in order to compare the maximum values, I need to find the maximum value of f of x. Okay, so here I'm given f of x. Okay, and f of x equals negative 0.3 x squared minus 0.6 x minus 0.2. The a value is negative, so it faces down, so I know it has a maximum value. Okay. In order to find the maximum value, I need to find the vertex. The first step in finding the vertex is to find the axis of symmetry. And that's x equals negative b over 2a. Okay, so that gives me x equals, my negative b is right here. So it makes it, when I plug a negative 0.6 into a negative b, it makes it a positive 0.6 divided by 2 times the a value, which is negative 0.3. Zero 0.6 divided by 2 times negative 0.3. Ooh, that was interesting. Gives me 2 times that is negative 0.6. And then 0.6 divided by negative 0.6 is negative 1. Okay, that is not the maximum value though, right? Okay, that's the x value, so you have to plug it in. Okay, so we're going to plug in negative 1 to find the y value. So I'm going to have f of negative 1 equals negative 0.3 times negative 1 squared minus 0.6 times negative 1, and then minus 0.2. Any questions? Okay, so let's do that math. F of negative 1 equals negative 1 squared is just 1. Negative times a negative makes us a positive 0.6. This is 0.3, negative 0.3, plus 0.6 minus 0.2. That gives me 0.3 minus 0.6 would be 0.3, minus 0.2 is 0.1, positive 0.